Okay, so let's move on to the next problem. So a cube is a solid figure with a 6 face. Yeah, this is the cube, right? The 6 face, and each face we have 6 opposite face, right? This is 1 pair, 2 pair, 3 pairs, 6 face, and each one is a square. The surface of the cube is the total area of the surface when increase the side length. Okay, let's assume the side length is x, so each square is x square, so 6x square is before, right? If the side length increased by 4, the surface area increased by 576. Okay, now let's solve this equation. So this is equivalently divided by 6 is x plus 4 square equal to the x square plus the 94. Then the x plus 4 square minus x square equals 96, right? You use the difference of the square, you can see it's 4, and 2x plus 4 is equal to the 96. Then you can divide by 8, so x plus 2 is equal to 96 divided by 8 is 113. No. Let me see. Yeah. X equals to 10. Okay. Now what's the volume of the original cube, right? So V is equal to the 10 to the 3 is 1000 is the final answer. Next. So suppose the quadratic, this one equals 0 when x equals r or x equals s. Then if we know this, okay, so basically we know the roots is rs, so we can write them down. So r plus s equal to the negative of the b, and r times s is equal to the c, right? A is 1, this b, right? And this one is 10, and b and c are integers. Okay, so okay, so let's see. So r plus s, right? And rs, right, is equal to negative b times c is equal to 10, right? So we can write the b times c is equal to negative 10, right? We know b and c are integers, right? Let's list them, okay? So b and c, okay? So if b can be, for example, can be positive negative 1, then c is negative positive 10, right? B can be positive negative 2, is negative positive 5, b is positive negative, find all the factors, right? The 5, negative positive 2, and the b can be positive negative 10, c is negative positive 1, okay? Because they are all integers, right? b, c belong to integers and integers. So now it's the solution. Next. So consider the quadratic. Notice that the quadratic cannot be factorized into the product 2 that this means the quadratic does not have real solutions. Okay, so let me talk about the quadratic equation and its solution. Okay, so we have the ax squared plus the bx plus c. Okay, now let's do the take out the a. Okay, so x squared plus b over ax, right? Let's do the b over 2a square. Okay, then because we're adding this one, right, we need to take out the 4ab square plus the c, right? So we have the a, then this one is x plus b over 2a square. Okay, then minus 4ab square minus 4ac. Okay, then if this one equals 0, right, let's see. So x plus b over 2a square is equal to the 4a square, right? b square minus 4ac, right? So this one, left side is something square greater or equal than 0. So you know on the right side, the denominator is already greater than 0. Then we need b square minus 4ac greater or equal than 0. Okay, if this is the case, you have the roots, right? X plus b over 2a is equal to plus minus 2a b squared minus 4ac, and we always define the delta is b squared minus 4ac. Then we have the solution x1 is equal to negative 2a, then b plus x1 2 is equal to, let's write them together, this one. Okay, so this is the general solutions to the quadratic format. So now let's see this problem. Okay, so 3 square b is 3y squared minus y minus 12. The delta is equal to b squared minus 4ac is greater than 0, right? So definitely there is a solution. Suppose quadratic has solutions. Let's find quadratic roots for this. Okay, so if this one has the solutions of the R and S based on the Vieta theorem, right? So R plus S is equal to a over negative b, right? That's negative 1 is equal to a is 3, 1 over 3, and R times S is to negative 12 over 3 is negative 4, right? Okay, now we want to find the quadratic equation with the roots this, right? So if these are roots, right, that's calculating the coefficients of new equation, right? So this is the sum of the roots is equal what? Is equal to the 1 over 3 plus the 4 is 3 over 13, right? So the coefficients, the x coefficients, right, is negative 13 over 3. Then the product of the roots is equal to rs plus 2r plus s plus 4 is equal to negative 4 plus 4. Okay, cancelled, plus 2. Now 1 over 3 is 2 over 3. Okay, so the constant is 2 over 3. Okay, so therefore the equation is x squared minus 13 over 3x plus 2 over 3 equals 0. Next, okay, so at his usual rate, man rows 15 miles downstream in 5 hours, less than it takes him to return. If double the usual rate, okay, 15 miles, okay, the 5 hours less than, right? And double the usual rate is 1 hour less than. Okay, so let's see the rate, the row speed, and the current speed. X and Y. Okay, so we know the 15, right? So when we go down, it's x plus y faster plus the 5 hours is equal to 15. When we go back, is slower. Then the other one is 15. Then 2x plus y. We doubled it, right? Then is less than 1 hour less than 1 equal to 15. The 2x minus y. Okay, question is asking us what is the y equal what? Okay. So this one, let's see, is we can solve this. We can move this one here, like the difference of the square. So 5 is equal to the 15, right? So it's equal to the x squared minus the y squared is 2y. Okay, here it's 1 equals 15, right? So it's the 4x squared minus the y squared. Then it is the 2y. Okay. So let's see, this is the 1 and this is the 2. And let's use the 1 over 2. Okay, so we have the 5 equals the 4x squared minus y squared is x squared minus the y squared. So we can have the x squared is equal to the 4y squared. Means because the speed is always greater than 0, right? So we have the x equals 2y. Okay, now we have the relationship of the x equals 2y, right? Let's put this one back to here. Okay, so 1 is equal to 15 times the 2y over x equals 2y. So it's the 2y is 4y, it's a 15y squared. So now we get y equals 2. Okay, next. Okay, so we have this equation set. 1, 2, 3. Okay, so let's observe it. So here we have the a squared minus plus b squared, right? But we don't have a squared, b squared here, right? But you're observing the 1 and 2. Here we have the 7 here with the 7, and we have the AB, and we have the BA. So it seems that using 1 and 2, we can getting something, right? Let's cancel something, right? 1 minus 2, because the right side can be cancelled as 0, right? Let's see the left side. AB are gone, right? So it's AC minus 5A, then minus the BC minus 5B, right? So equals to 0, because you can see if we take out the C, A minus B, then minus 5, right? Minus 5, then A minus B is equal to 0. So now we can factorize it is A minus B, and the C minus 5 is equal to 0. Okay, so if you want to satisfy this, there are two cases. Case 1 is A equal B, and the case 2 is C equals 5. Okay, so let's discuss these two problems separately. Okay, so I think A equal B is easier to solve, right? If we know A equal B, then we have the 2A squared is equal to the 50. Then you have the A equals plus minus 5. Then also B equals plus minus 5, right? So now we can put it back. We can put back here. So put back to equation 1, okay? So A equal B, for example, A equal B equals 5. So we can have the 5 and the 5 plus C minus 5 equals 7, right? So you can see C is equal to 7 over 5, right? So if A equal B equal negative 5, so the answer is 5, 5, 7 over 5. And A equal B is negative 5. So you can see C equal is negative 50, 43 over 5. So it's negative 5, negative 5, 43 over 5. Then if C equal 5, right? Let's do the C equal 5. Let's put C equal 5 into the 1, okay? So it's AB plus 5 minus 5 equals 7, right? So we have the AB equals 7. And we have the A squared plus B squared equals 50, right? This one can remind you something, okay? So what is A minus B squared, right? Is equal to the A squared plus B squared minus 2AB is equal to the 50 minus the 14 is equal to 36, right? So from here, what you can get is A minus B is equal to the plus minus 6, right? So if A minus B is plus minus 6, right? So you can see, we can see is A equal the 6 plus B, or A equals negative 6 plus B. Okay, now let's put them back. We can put them back. A equal this, A equal this. We can put them back to here, okay? So let's see. So 6 plus B times B equals 7. Then we can see the B squared plus 6B minus 7 equals 0, right? So we have the B equal negative B plus 7, negative 7, yeah, or B equal the 1. Okay, so this is the B. So then let's do it. Okay, so the final solution, we know for this one, we have the a equals 6 plus b, right? 6 plus b is -1, -7, and 5. A equals 6 plus b, so it's 7 and 1 and 5. Okay, that's the first case. The second case is a equals -6 is b minus 6, okay, times b equals 7. So this one gives you the b squared minus the 6b minus 7 equals 0. Now it's b equals 7 or b equals -1. So if b equals 7, right, a equals 1 and 5. Okay, then b equals -1, then b is -1, a equals -7, and then here is 5. Okay, so these are all the solutions. 1, 2, 3, 4. Okay, so yeah, this is it's just not difficult, just you need a lot of casework. Next, so this one is infinity. Okay, so this one we use the replacement. Okay, so you can see if this is the x, right, if x equals square root of 90 plus 90 plus forever, okay, always we can think this one is x. You can see this one is also x, so then we can construct the equation is right, so we know x should be greater or greater than 0. This is a positive square root, right? Then x squared minus x minus 90 is equal to 0. So x minus 10, x plus 9 is equal to 0. So x equals 10, because the other x equal -9 doesn't make any sense for x greater than 0. Okay. Next, so Joe is thinking a quadratic and Eve is thinking a quadratic. Both x are their variables, and the value of the quadratic for x equals 1, they get the same number. Okay, so let's see. The quadratic is ax squared for Joe. Okay, let's see. Plus bx plus c, right? This is the quadratic fx. So for x equals 1, so we know a plus b plus c, right? For example, if we have the equal to m, for x2 they are also equal, right? So 4a plus 2b plus c is n. Then for x equals 3, they are again equal. 9a plus 3b plus c equals p. Okay, so because the Joe get this, and also the Eve is dx squared plus ex plus f is also get the same thing, right? So as long as we can solve ABC in terms of M and P, right? We can also solve the DEF in terms of the M and P, right? Yeah, so how we solve it? Let's do it. So let's use the 1, 2, 3, right? So first we want to make it 3 variable, 2 variable, right? So it's easy to eliminating the c, right? Because we don't need to times. So the 2 minus 1 is 3a plus b is n minus m. That's 4. And 3 minus 1 is 8a plus 2b is p minus m is 5, right? So now we can try to eliminating the b, right? So the 5 minus the 4 times 2 is equal to the 2a equals 2, the p minus m minus 2n minus m, right? So we can solve the a is 2 over p minus 2n then plus m. Okay, so and also we can try to solve the b, right? B is equal to 2 then 8n minus 5m minus 3p. Okay, so you can see basically we can solve the ABC. Okay, we can solve the ABC. So that means once you know the m and once you know the m and p, right, the ABC can determine deterministic. So the same thing you can solve DEF, right? So now you know that A equals D, then B equals E, and C equals F. So the two quadratics are exactly the same. Okay, that's all about the challenge problem for this chapter. Thank you.